All right, so we still have a strong base as our analyte, which means it's floating around in the flask. So if I drew a little picture of the flask, it has, that's a terrible flask, but whatever, it's fine. We have 25 milliliters of NaOH. I could restart the video, but my flask would still suck, so we'll just let it go. All right, so there's flask. I think I even need to label it because I think you can't tell. All right, got 25 milliliters of base in there initially. And then we're going to take our burette, right? Here's our burette. It has some acid in it. But we're gonna start up here somewhere, and we're gonna drain 5 milliliters of drops of acid down into my flask here. So that's what's happening. Now, every time one of those drops of acids hits base, base is converted to water and that neutral salt, and so that base goes away. So what we have is the thing that was in the flask before, or the strong base, the thing that's being added, or the titrant, and then those two are going to come together, and they're going to make that water molecule, and they're going to make that neutral salt all the time. So if I'm adding this, this is going to get consumed because acids react with bases, and both of these are going to be formed. Now, we don't really care what's formed. What we want to know is what the pH is at the end. So we have to figure out how much NaOH we had initially, how much NaOH is consumed. So if I take the initial amount, I minus what's consumed, I'll be left with the remainder. Now, I have a molarity and a volume for NaOH. I have a molarity and a volume for HCl. And I can't compare molarities to molarity because there's a different number of moles, there's a different volume, and that's not stoichiometrically proper. We learned that in 115. However, I can pretty easily get to moles. And so if I figured out the moles of base that were there initially, the moles that were consumed, then I would have the moles that are left over, which I could then divide by the total volume. So I'm going to start with the moles of NaOH that were initially present. Not a word, it turns out. It's crazy handwriting. You're just going to take the volume, has to be in liters, times the molarity, and you're going to get a relatively small number for the moles of base. That's a minus sign, -3. Now that's the initial one, right? So that's at the beginning. That's what we just found. Now to figure out the moles of base consumed, well, there's nothing up there that tells me moles of base consumed, but I do know the moles of acid that were added. And I know that acids react with bases. So as I add that acid, I must be consuming base. So I'm going to figure out how many milliliters of acid there are and take the molarity of the acid, because it's those acid moles that are going to have to react with my base. Okay, well, I wrote acid here. So moles of base. Okay, that's a minus sign again. Now, the moles of base initially are greater than the moles of acid that I added, which is good, which means that we have some moles left over in solution. And all I have to do is subtract these two numbers. So here's what I had initially. Here's the amount of acid that I added, which means the amount of base that was consumed. And here is the difference between those two. Turns out that we had 25 milliliters in the flask to begin with, and then we put 5 milliliters on top of that. If I add 5 and 25, I get about 30 milliliters, or 0.03 liters. That gives me a concentration of 0.152 molar. Now remember, that is a concentration of hydroxide ions because it's NaOH that is in solution. So I can take the negative log of that value, But when I do that, I get the POH, which happens to be 0.818. It's tenintsi. I can subtract that tenintsi number and get the pH.